Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 6 of lesson number 9, Force and Laws of Motion. Now in part 5, we discussed on how can we mathematically derive the formula that is momentum P is equal to mass into velocity, right? That is like mv. So we mathematically derived that. Even we came up with the formula that force is equal to ma, that is mass into acceleration, right? So till now we are almost done, like we are done with the first law of motion. And as the lesson also has about force, we even discussed on two different types of forces, that is balanced and unbalanced force, and effects of force. We even discussed on that. Then after that, after discussing the effects and types of forces, we had few activity, and then we started with the first law, which is law of motion, which is also known as law of inertia. So again, we started that with different examples and activities, right? And after that, we started with the second law of motion, right? We even mathematically derived that. Now we have like 6 different examples and few activities, I guess, which we will be discussing with respect to second law of motion itself. Because like you understanding second law of motion with respect to like all the real life examples are very important, so we will be doing that itself in this part. And eventually if we get time, we can even start with the third law. Now third law is not that descriptive, but still we have many examples, like solid examples, which are given after, you can say, third law of motion. And then we have conservation of momentum to study. So we'll be studying all of that in the lesson. But before that, before I proceed with today's part for the lesson, I want each one of you to please revise whatever notes you have taken in your book, starting from part 1, because that is what is going to help you now. Okay, so please revise it, everyone. I hope every one of you are revising it. मेरा button. So I'm going to show you the slides one by one, and I want you all to have a quick glance through that as well. So we have started the lesson by discussing on what is motion, and here we have the exact definition, the SI unit for it, and what force can do on a body. Everything has been given along with few examples on the top. So I want you all to please quickly go through the slide, everyone. So while you were having a quick glance through this, I hope you have even revised about the definition on push and pull that I gave you in part 1, because that is also very important and you need to keep on revising that as well. Okay, now after this we discussed on the effect of force, and we studied that effect of force can be understood by the following points: that the force can increase the speed of a moving object, it can decrease the speed of the moving object, it can move the stationary object, it can stop the moving object, it can change the direction of the object, it can even change the shape and size of the object. We discussed each and everything, right? So I just want each one of you to please revise everything. You should be able to write this all in your own words till now. Then we discussed that force can be of two types. One is balanced force and the other will be unbalanced force. So on this slide we have information on balanced force which has been given along with an example. So I want you all to please revise it as well. I hope every one of you are revising it. I hope every one of you are going through the slide, and if possible, like here we have one of the example given. I want y'all to like go through this and have more examples with you. Okay, like there are so many examples of balanced force around us. So make sure you know them all. Okay. After this we discussed on like unbalanced force. So I want each one of you to please go through it as well. So sorry. I hope, like, as I told you to add some additional examples apart from the one that has been given here. For balanced force, same way you have to write some examples for unbalanced force as well. Okay? Then after that we started studying about the first law of motion. So here we have brief information on you can say first law of motion which has been given. So I want each one of you to please go through the slide quickly as well. I hope you all are going through it. And here we have one point that Galileo has argued regarding the marble which has been released from left. He said that it will roll down the slope and will go up on the opposite side, right? So, like regarding this, we have like discussed further as well, like what exactly was happening. So you should be aware of it as well. Okay? After this first law of motion, here we have like more information about the angle of inclination, which has been like angle of inclination of the marble that has been given. So we'll discuss on that, like we will discuss on that as well, but I want you all to quickly go through it, okay? Because this slide is again very important for us. After this inclinations and all, we discussed on like what exactly was studied by Newton on Galileo's idea, and because of that, because of like the study of the Newton on Galileo's idea, we came up with three different laws, and which we know it as Newton's law of motion. So from here we started with the exact first law of motion, and it states that an object remains in state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. In short, all the objects are going to resist a change in the state of motion. Okay, so and remember one thing as well, that first law of motion is also known as law of inertia. What it is also known as? It is also known as law of inertia. So I just want each one of you to please go through it. I hope you all are reading it. See, not only reading it, you have understood it, and like you will be able to write this big answers on your own. Like if I tell you to write first law of motion, you should be able to write it for 4 to 6 marks anyhow. Okay? After this, we discussed on this part as well. So I want you all to please go through it. Then we have this activity 9.1 that we discussed. Like we have 2-3 activities all together. So I want you all to please go through it quickly as well. After this activity 9.1, we even discussed on 9.2. So please go through it as well. After that, we discussed on activity 9.3. So I want you all to please go through it as well. After this activity 9.3, we discussed on inertia and mass. So I want each one of you to please go through this as well. Then we started discussing about the second law of motion. So I just want you all to please go through it, and even here we have the information on momentum and everything, what exactly momentum is, and like different examples have been explained over here as well to make it easier for you to understand the second law. Okay, so I just want you all to please go through it as well. This slide is very important, so I hope you all are going through it. So I hope you all are going through it as well, as this is also very important for us to know. Then after this, like we discussed on calculating like mathematical formulation of the second law of motion. So I want each one of you to please go through this as well quickly. Now this is very important question as well, so make sure you know it. I hope you all are going through it properly. After this, we discussed on like the further explanation on the second law that we have, right? So I just want you all to please go through it quickly. After that, here we have like the formula that we derived according to the first law, like which is mathematically represented as F is equal to ma, that is mass into acceleration, right? So I just want you all to go through this slide as well, because here we have information on more about momentum in short, right? And how exactly we can calculate force as well from momentum part, right? So that explanation has also been given on the screen itself. I hope you all are going through it and you have like properly understood as well what exactly we were discussing on it, right? After this, like now we have 4 to 5 examples on the same, like discussing about the second law of motion. So here we have to calculate the final velocity of the object based on the information provided, right? So let's see what the example is. A constant force act on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. And now if the force was applied for a duration of 5 seconds, earlier it was like the velocity was from 3 to 7. Now if the applied force is for the duration of 5 seconds, what would be the final velocity of the object? So what do you think in this case? Right? So let's see what solution we can come up with it. So we have been given that u is equal to 3 meter per second. U is the initial velocity and v is the final velocity. So that is 7 meter per second. So 3 and 5 meter per second, and time taken is 2 seconds, right? So t becomes 2 and mass is 5 kg. So this is the given part that we have. Now from equation 9.5 that we had derived, that F is equal to mv minus u upon t. You have everything. So what we have to do, we have to just substitute the values, where F is equal to m is 5 kg, initial velocity is 7, sorry, final velocity is 7, initial velocity is 3. So 7 minus 3 upon time taken is 2 seconds. So on basis of that we can calculate force, and once you calculate it, you will get the answer as 10 Newton. Because we are calculating force, the unit that we are going to use over here is Newton. Okay, now if this force is applied for a duration of 5 seconds, okay, we are applying the same thing for the duration of 5 seconds, where t is equal to 5 seconds, then the final velocity, we can calculate that by rewriting the equation as we again had derived this. So like we have to just substitute the formula. V is equal to u plus ft upon m. So on substituting the value of u, f, m and t, we get the velocity as 13 meter per second. Now here they haven't substituted the value and have shown you, right? So I want you all to substitute the value from your end and check what exactly happens. I hope you all are substituting the value and trying to solve it. After this, the second example that we have is, we would require a greater force accelerating a 2 kg mass at 5 meter per second or a 4 kg mass at 2 meter per second. Okay, this is what has been required. Now from equation 9.4, we know that force is equal to mass into acceleration. So m1 is 2 kg, m1 is 2 kg, a1 is, that is acceleration, a1 is 5 meter per second square, m2 is 4 kg and a2 is 2 meter per second square. So thus f1 is equal to m1a1. So you'll multiply that and you'll get the answer as 10 Newton. F2 is m2a2. Again you're going to multiply it and you'll get the answer, and you'll get that f1 is greater than f2. Okay, so thus accelerating a 2 kg mass at 5 meter per second will require a greater force. So it's just the simplest thing. What you have to do is you have to just multiply the mass and the acceleration, and which is more is going to require greater force. Okay. After this, we have the third example over here, where a motorcycle is moving with a velocity of 108 km per hour, and it takes 4 seconds to stop after the brakes are applied. So after we apply the brake, it will take more 4 seconds to stop that. So calculate the force exerted by the brakes on the motor car if its mass along with the passenger is 1000 kg. So now you have the initial velocity which has been given to you, that is 108 kilometer per hour, right? So what we are going to do is we are going to convert that to meter per second. So for that, 1 kilometer is equal to 1000 meter, right? So we will multiply that with 1000 meter, and we know 1 hour is equal to 60 seconds. So we'll do that again and you will get the answer as 30 meter per second square, and the final velocity of the car is going to be 0, that is v is going to be 0 meter per second. So now the total mass of motor car along with its passenger is 1000 kg. Okay, now when the passengers sit inside it, the mass of the motor car becomes 1000 kg, and the time taken to stop the brake to stop the motor car is 4 seconds. So from equation we have the magnitude of force applied by the brake. So here we will be applying the formula as F is equal to mv minus u upon t, and we are going to substitute the values. Once we substitute the values and calculate it, you will get the answer as 7500 kg meter per second or minus 7500 Newton. So both the answers will be correct. Okay. After that, we have one more example as 9.4, where a force of 5 Newton gives a mass m1, an acceleration of 10 meter per second square, and m2 an acceleration of 20 meter per second. So what acceleration would it give if both the masses were tied together? So again, we are going to use the same equation over here, that m is equal to fa. Now we know F is equal to ma, right? So we are altering it because we need to calculate the mass. So instead of multiplication, it will become division now. So m is equal to F upon a, and using that we are going to calculate the thing. So you will get the mass m1 as 5 Newton per meter second square or 0.5 kg, and m2 as 5 Newton per 20 meter square or 0.25 kg. Okay, so if we are going to tie two masses together, the total mass will be m is equal to 0.50 kg, 0.25 kg, and like you just have to add on that. Okay, and at the end they have asked us that acceleration A produced in the combined mass by phi n force would be A is equal to F upon A. Now again the formula is same, F is equal to m into A, that is multiplication, but over here because we are altering it, multiplication changes to division, so you have to do it like that way. Okay. I hope every one of you are going through it. After this, like, we will be discussing on this last example 9.5. Now see, the velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in this figure 9.9. How much force does the table exert on the ball to bring it to rest? What do you think? How much force will be needed by the table to bring it to rest? So if by looking at the figure you'll come to know that the initial velocity of the ball is 20 centimeter per second. Velocity is measured in centimeter per second, right? So because of the frictional force exerted by the table, velocity is going to decrease to 0 in 10 seconds. Can you see 20 and 10? We have a green line over there. So it means the velocity is decreasing to 0 in 10 seconds, and thus u becomes 20, v becomes 0, and t becomes 10 seconds. So since velocity time graph is a straight line, it is clear that it is moving with a constant acceleration. So here we are going to use the formula as A is equal to V minus U upon T, and we are going to substitute the value. And after that, we are going to calculate the force by using the formula F is equal to M into A. Okay, so because we are going to obtain this answer in negative, so negative sign implies that the frictional force exerted by the table is opposite to the direction of the motion of the ball. Okay, I hope you all are going through it. Now after this, we are left with the third law of motion that we will be discussing in the next part. But I hope like whatever we discussed, whatever examples that we have discussed in this part of the lesson, every one of you are clear with it, right? So we will start with this third law of motion in the next part. Then like we have many different activities and examples to discuss in the lesson. We will be discussing that. We will be even discussing on conservation of momentum in detail. Okay, and we are going to start that again in the next part itself. So we are left with this, and then we have activity 9.5 as well to discuss. So we'll be doing that as well. Okay, then we have activity 9.6, we have 9.7, 9.8, and all the activities we will be discussing on. Okay, and after that we will be discussing on the summary for the lesson, like what exactly we have studied so far. We'll be doing that, so make sure you know whatever we discussed like in this part, so that we can proceed with the further part in the next class. Okay, and then we have few exercise questions that we will be discussing on, so I want each one of you to please go through it properly. There are total 18 to 20 questions which we will be discussing. Okay, I hope every one of you are going through the questions. So as I told you, like we have 18 to 20 questions, we will be discussing each of them, where you will be calculating each and everything. Okay, for that you have to be clear with it. Like today, as we discussed on all the examples, where we saw how to calculate acceleration and all using different formulas. So I hope you have understood them all, because you're going to do the same thing over here as well. Okay, so there are total 18 questions that we will be discussing for the lesson force and laws of motion. Okay, so make sure you revise it and you understand the concept well, because I will be continuing with the rest of the part in the next class. Thank you everyone.